Great, thank you. But before I present the first question to the panel today, I really want to spend a couple of minutes describing what worked best from an organizational perspective for software security groups I've managed, and some of the folks on the, actually all the panel members have managed as well. I want to kind of set the stage for what we're talking about today. It may be a little different view of software security than what you've heard before. And although InfoSec has had a role in oversight for application and product security, I strongly believe its functional and operational roles belong in engineering, and that you must build trust by empowering the developers to create secure software. Doing more with less, of course, is the reality that we all face, regardless of the risks that we are facing. And to help solve this conundrum, I worked with my previous teams to build models for a software security group that didn't depend on continual growth, linear or otherwise. Our virtual teams grew against linear growth, allowing a fully staffed centralized software security group to remain relatively stable and small in size. And we believe that a centralized group combined or comprised of one seasoned software security architect per main software product group and one software secure engineer and champion for each software product within a software engineering development organization was sufficient and scaled quite nicely. A key element of the talent that we had was that the software security engineer, evangelist, and mentor were developers first and security experts second. And as part of each product or applications development team with the ability to grow into group software security architect over time. And I'm sure Brooke will talk a little more about that as we get further into some of the Q&A. In addition, by sharing the responsibility for a typical product security incident among the key software security engineers for each software product in a development organization, a single PCERT manager or a very small team, depending on your culture, suffice to give the responsibilities of the tasks were just because they were distributed throughout the whole organization. Essentially, you had the developers that were the PCERT team rather than these huge PCERT teams that people try to create. You had some oversight, but minimal at best. And each of the seasoned software security architects on the centralized software security group coordinated and supported the implementation of the SDL within each business unit and software products lines, while mentoring and coaching the software security engineers that were responsible for each product. Of course, having the software security experts reporting to the engineering organization means that they are empowered by the fact that they are part of the same organization as development, are directly responsible for implementing the SDL policies and procedures and associated tools, and understand software development, its architecture, and level of effort required to fix the issues. So let's move on to the first question for the panel. So how do you define software security, and where do you believe the responsibilities for it belong from an organizational standpoint, and why? And also, in your answer, if you could touch on what you believe the current state of software security is within most organizations you work with or part of. Jim, I know you've got a lot of passion in this area. If you could go first, that would be great.
Software security to me is when developers follow a rigorous standard of requirements that drive functional and non-functional security within software. So I like to reduce software security down to a simple engineering problem. You're building certain functionality and non-functional requirements into your software, and then you're testing and verifying that that's being done correctly. So to me, it's essentially our developers, writing software to a clear security standard. This is why I'm a member of a standard called, it's an open source standard, a lot of other people work on it, called the OWASP Application Security Verification Standard. And that's an extension of my answer, because because a lot of software security is nitty gritty details that we often lose track of. And yet those nitty gritty details are where the rubber hits the road in terms of secure software. So and this is a really hard term to define. I'd like to also answer. I try to avoid philosophical answers or non-actionable answers. So I'm trying to give you it's a complex answer, but it's actionable. Develop software to a clear standard such as the OWASP Application Security Verification Standard. So all the nitty-gritty details of developing secure software is addressed in and day out within your software group. And by the way, James, I loved your introduction. I always look for like something that I can critique. Every single word you said in your introduction, I stand behind as well. I think that was a great introduction, and it's an important summary of how we should be addressing software security. So I'm a big fan.
Great, thank you very much. Let's move on. Amal, what do you think about that question? A different view or a different way of looking at it all?
Sure, I'll try to go after Jim and see how I do. Let me get a disclaimer out of the real quick. I'm here as a researcher and a thought leader, not in the official capacity for my company. Coming back to the question, James, you posed, I would like to leave philosophical and the team structures out of it, right? But as far as the discipline goes, right, I think what we have done in the security industry and explosion in the interest in this discipline is confused the discipline, which is software security or code security, and we can talk about nomenclature, with the team structures of how that framework essentially is applied in the real world. And that's really the dichotomy that you see, the disconnect between how it should be versus how it is in the real world. I look at these conferences and I look at these sessions that come out. And here is I'll quantify what Jim was saying. This is something that we have tried to do over the years. If you're not spending 75% of your time with a developer, or you're not spending about 75% of your time on design, then you are not doing AppSec. In the sense for code security or design security, right? You are doing anything but that, and that is tools support, Jira tickets, you name it, you are doing it. But I think if you want to talk about the discipline, not the team structures, the discipline is, can we make code secure as much as possible? And then can you also make the design as secure, right? And if you take those two elements, that's the software security. You can call it by any other name, but that's what I see. And I can come to the current state because I think it has ramifications. James mentioned the framework that we more than a decade ago have been practicing. And what I see today is, since you asked what is the current state of affairs in the industry, largely I look at the data and all the Verizon report, all this comes out. Roughly I look at penetration testers or a team or that sort of security testers ending up in the software security discipline, right? And then that's, to me, is like hiring a demolition man or a woman to build your home, right? And that right there is, that's where you start seeing the culture clash, because I think what you will find as we go in this panel forward is that we know how to do this. It's not rocket science, but I think we have made it more complex than it needs to be. We have confused the discipline with the team structures, and it gets even more complicated because we focused on developers, but let me give you some practitioner's view, since all of you have joined us on a Tuesday evening. So you had the traditional issue where we needed to do software security on the product itself, right? As we moved into cloud, as you get into ISE or infrastructure as code, and you need to do that pipeline, like the integration to deploy a pipeline and secure it. You then need to think about what code itself means, right? Code no longer means writing Java or a higher level language. Code now also has the infrastructure components to it, the glue that comes along with security, integration, APIs, all of that. So just like we need the software engineers to come in and help us to do great software security, we need infrastructure engineers to then come and pick up that coding, because software engineers will think of in terms of software products and platforms. Cloud, you need discipline. You need the 5 nines availability. It's a very different mindset. So just like you can't train a developer, right? You can't to do the ops. I mean, you can. It was going to take time, but you can't do the role swaps right away. And I think between misunderstanding of the framework and the team structures, and also not paying attention to what kind of talent we hire to solve this problem structurally, has resulted in the overall state of software security as I see it. Hopefully, that gave you some, James, did that cover what you were looking for?
Oh, whatever, it's your guys' show to talk about what you believe is the most important things about software security today. I'm just kind of poking the bear here. Jim, did you want to say something before we moved on to Brooke?
I think one of the big trends is that developers and operations are coming closer together. We see developers spinning up their own servers and maintaining cloud instances. So that division between developers and ops is fading and fading quickly. At one level, that's good. We have more operational responsibility in the hands of developers, but it's also bad in that developers don't have real experience traditionally in this area. So I think that trend, I think, is exciting, but also it concerns me a lot. So even though I talk about requirements for developers to write secure code, developers more and more need to also, at least as part of their team, they need to understand these operational issues really early on in development lifecycle with all the emerging cloud, Kubernetes, spin up infrastructure type of culture that's becoming the norm. And so this is something I don't think we're ready for. This is why we see like, Capital One getting popped with server-side request forgery, and there goes 100 million records, and similar problems where it was a shared developer operational issue. So I think we're going to see more of that. It's going to get worse before it gets better. One more quick thing before we go to Brooke. You asked about like industry trends. How are people doing, right? Well, my customers are doing fine. No, that was a joke. That was a bad ego joke. But yeah, thank you, Brooke, for getting. No, I mean, I see folks all over the map. I see some companies, especially like mature companies making a lot of money in web software, where they really don't want to engage security developers, and they're trying to do the minimum they can to keep the money coming in, because it's a big expense to take a legacy group and turn them into a core software security James Ransome certified group. That's a giant expense to go from legacy to that. And a lot of companies don't want to, so they'll still do the minimum to check the boxes to keep the money coming in. And until they get hit with a difficult incident, they're not likely to make real big changes. On the other hand, there's some groups that are like drinking the Kool-Aid of DevOps all the way and have elaborate developer-driven pipelines and are extraordinarily mature. And so I see the industry from my 100 customers or so, like all over the map in the bell curve right now.
Yeah, no, I agree with you. Go ahead.
Just add one more thing. Since Jim set up the stage, I will just take it from where he left. By having this perfect mix of the DevOps and in a way we have democratized compute and we have allowed people to scale, and that's awesome, because that's where you see a lot of innovation coming in. What has happened though is that same innovation can result in attacks at scale, right? You essentially compromise the pipeline at the source, and you're done. You have done the attacker's job for them, right? So it's a very interesting paradigm that you live in these days. But I do want to sort of give you a picture of what it used to be. And I think it was 2011, 2010, Sony went down, but at least the PlayStation. And the product security as a concept was not very, as a discipline, was not very well adopted. So we have come far from where we started 15, 20 years ago, that we have people like James, and then there's the appreciation of what product security needs as a discipline. I think we have been slow to adopt that, and then with the confusion caused by tool sets and nomenclatures, I think that has impeded our progress a bit, but we have made progress. And then I'm sure we will solve this problem one way or the other, and I'm sure we'll come to that later on.
Great. Brooke, let's hear from you on this. I know I was going to step in there for a minute, but I think we'd be saying the same thing. So go ahead.
All right. Well, I'm going to go in a little different direction, because I think Jim and Anmol covered this a bit. I'm going to tell you that in my rather informal surveys, but talking to thousands of developers, which I know Jim also does on a regular basis, there's the problem is that software security isn't well understood We say that, or they say AppSec, or, you know, call it as other people have said, call it what you want. I don't care. What's in the name? Would a software security smell as sweet? Who knows? But nevertheless, what's been really consistent in my little surveys has been when you say software security, the same 3 or 4 things have been incredibly stable since Michelle Koblis and I started AppSec back at Cisco in 2002, was it? I think it was, yes. Something like, 2002, 2001 might have been, late 2001. Anyway, we were there, believe me, together. And if you talk to people about software security, they will go to one of 3 things. They will think about some sort of encryption, probably TLS if they're doing web security, but maybe if they're doing something else, they'll think of some other type of encryption. Or they'll think of coding security and the tools that help you with that. That's been incredibly stable. Or they'll think of authorization and authentication. And this has been incredibly stable for 20 years. I want to say 20 years. People don't realize just how holistic you have to think. Now, I've thought about that problem and tried to get around it. Being an architect, I like to know what I'm designing to, because I can't design unless I know what I'm designing. So, and I was really heavily influenced by the enterprise security people at Cisco, I have to say. I was. They taught me a huge amount about being a much better architect over the years. And I think my architecture and design skills have improved remarkably because of what I learned there from these incredible people who basically invented and drove enterprise architecture as a discipline. But what they taught me is you got to write up principles that you drive for. So if I could hand you any tool, and by the way, Jim Manico's, or OWASP, with Jim has been powerful on it, the verification standard has a lot of stuff in there about what you have to build and how to go about it. So if you're looking for cheap principles, there's not a bad place to start. Or go to the continuous threat modeling and the continuous threat modeling guide project on GitHub, and go to the continuous threat modeling guide. And that little guide has a whole bunch of situations. And if you run into those situations, it tells you the sort of things you should do. Those are principles. You could do them, or you could take mine out of one of my books or whatever if you wanted more high level stuff. But you got to know what you're designing for. And it's a lot more, as Jim made the point. When we talk about software security, it includes not only the software you're designing and how it will have its functional and non-functional security properties, but it will also include the whole build, repository, build, release, deploy, operate chain, because all of that's code, as Anmal just said. All of that's code today, or a lot of it today. And so you have to look at that as code, and you have to look at it as part of your software security universe. A lot of times, most of that stuff I find is built for the convenience of the developers, because they're just trying to get their job done. It's not that they're unclueful or anything like that. It's just, I want to get my job done. It's easier if I have the run of everything so I can do what I need to do. And, you know, once you get 10,000 customers, that's a very bad scene, because somebody's going to make a mistake, or worse, you're going to have deep cover, or, you know, whatever. Lots of things can go wrong. So that's where it begins to fall apart at scale. So, you know, you've got to include that. You've got to include every bit of code, the support code. Do you remember, James, there was a certain product that had a little utility that was only used as, James going to start laughing. That was a little utility. It was only used by support people. And oh my God, it got us into so much trouble. Yep. Little utility, but it was out at tens of thousands of uses. And it was, you know, had an RCE in it. Great. And so, you know, we got to look holistically. If I could make any point, don't limit yourself. And that's my problem with some of the terms that come up, is they limit us in focus, when in fact we have to take a wider focus. So that's kind of my little take. And thank you for setting me up, Jim and Anmal, with that, so I could, you know, go on about looking holistically. And if you're curious, again, I gave you a couple of standards, and we can get the stuff into the chat when I'm not talking, or you can look in one of my books. The new book has the principles, just like a couple of other ones do, however you want to get at that.
Well, don't think you've stopped talking yet. Oh, go ahead. Go ahead. Anmol.
Yeah, I just wanted to complete what Brooke was saying. Not as usual, right? He went, and so there is very little for me to add. But I'll go back to what he said. Code. What is code? And we have again new buzzword. We have shift left. Basically saying we should do things early in the SDL cycle. Something has been around for 20 plus years. I think Jim or someone else mentioned. Right? So it's essentially moving that early in the SDL. But if you look at where we are and what we are about to see, as I said, right, you have democratized compute. So you are going to now also have increasingly SaaS integration points into your environment. The reliance on in-house apps is going to decrease. So that also is a code, the glue code that you put in place through APIs and integration. That has to be a part of the practice. And also, if you look at some of the recent developments in the hardware, right, the code is also going to go down in your hardware and the chip. That's a code. I mean, that's not the topic for today, but that's code. That needs to be taken care of. So either shift left, down, right. I don't know. We can come up with more buzzwords, but the point is, if it's a code, it needs to be designed securely. It needs to be, written securely, and then in this new paradigm, it needs to be, deployed and run securely too.
Thanks, Anmol. Jim, anything else to add before we move on to our next topic?
I like what Brooke said. If you take a look at the ASVS standard, it includes architectural requirements, authorization, authentication, injection, process. So I think the point, it's not just TLS, it's not just authentication, it's not just access control, it's not just design modeling, it's all the above and then some. And I think that's, when I started working on the ASVS standard with Andrew Vanderstock, Daniel Cuthbert, Josh Grossman, Elar Lang, and many others, it's what amazed me when we saw the contributions for everyone is how we went from a pretty slim technical standard to a really broad process, technical, and many other aspects of software security. So to your point, it's not one thing. It's not just code. It is people, process, and technology, and a whole lot more to accomplish even remotely secure software. And that is a problem. That's a problem. The fact that we need this radical, major cultural, process, technical, and similar change is part of the reason why we've only been so successful. And I'm going to say that we've not been hugely successful in the last 15 years at software security. We've been a little bit successful at times, but overall, we're still struggling. And that's because the educational system, the technology we're using, the third-party libraries we depend on, the infrastructure that we depend upon, all has major fragilities by default. So yeah, we're making progress. Yes, we've learned a lot more, and I'm very optimistic about the future of software security. But you're right, it's not rocket science. You know why? It's more difficult than rocket science to really write secure software. Look at Cisco. Cisco has spent a huge investment in doing software security, and yet some pretty major end of times bugs have come out of their products. And I'm not saying that to attack Cisco
or Microsoft.
Oh, Microsoft.
Who does it the best?
Microsoft Exchange, vulnerabilities in Microsoft Exchange. By the way, remote code execution and a really wide open server-side request forgery problem that allows me to send a request to Exchange that then attacks the infrastructure as if I was Exchange, which is usually a root level Active Directory user from one of the most intense, well-funded software security groups on the planet. I really have a lot of respect for Microsoft and their efforts, and yet 4 bugs in Exchange has led to hundreds of thousands of organizations getting rooted. And so, yeah, to some degree, the problem's getting worse because we depend on software more. Even though we've learned a lot, I don't see things like getting better per se, except in my little intellectual circles of capability between friends. But overall, I'm scared for the future of software security. There's going to be a lot of pain before it gets better, if I have to be honest.
Thanks, Jim. Brooke, you kind of gave a good lead in to the next question I have, which is related to the discussion we're still on. What do you believe is in scope for software security, and what do you think we need to do about it, such as an SDL, or is it something else? And as part of your answer, also touch on why one single tool or approach can't take care of the problem.
Let's take that one first. That's one of the biggest problems is that I run into, and I'm very lucky. I get to talk to thousands of developers and hundreds of security architects in a year or two, just because of my life, and I feel really blessed by that. It's really a gift, but it also helps me understand sort of the world. And these aren't scientific surveys. I gotta admit, I haven't done any scientific surveys. But in my little rubbing shoulders with people, I find that one of the great myths is that I can do one thing and do it really, really well, and I'll solve this problem. And Jim gave the couple of examples. I mean, there's probably no better companies than Cisco and Microsoft and maybe Adobe at software security. They have stellar programs, and I learn a great deal from them. In fact, we were going to take them to task, Microsoft, in our book, and when I went to go check on it, they had already leaped to what we were going to take the task on. And so, you know, they're revising and learning and moving forward constantly and impressively so. Okay, so having said that, why do they still release bugs? Well, let me go back to something that you've probably learned when you were in college, if you have a CS degree or you've run into. It's called the Turing proof. And it says, in essence, that an automated process cannot prove an automated process is correct. The implication of that, along with Turing, what are called Turing complete languages, which just means there's a million infinite ways to express anything in these languages, is that we're going to have bugs. That it's very hard. And any of us who have written hundreds of thousands of lines, I personally have written hundreds of thousands of lines of system level and network level code before I started doing, you know, got sort of kicked upstairs to and do more design, but I have. And have you ever, if you're a coder, written something you were really proud of, and then when the bug came in from the field 6 months later, you looked at it and went, it's really good this isn't executing because it's all wrong? And I say this in front of developers all the time, and they nod their heads. If they're experienced, they nod their heads and go, yeah, that's happened to me, because it's really hard to write correct code. And for us mere mortals, I'm sure Jim is better than me, but for us mere mortals, I make a lot of mistakes, and sometimes they get released. And so, you know, that's part of the problem, is that we're trying to do our best with complicated things, and we make mistakes, and bugs get out. So this is a hard problem, and there's a failure in the tools. I'm sorry if there's a tool vendor on the call here, and I don't mean to insult your product, but there's a failure in the tools in that they're oversold. They're sold, I will solve your software security problem, when they address one part of the problem. And if you run them at their greatest ability, you will be inundated with too much noise for developers' tolerance. Might be fine for security people, but for developers' tolerance, they need stuff that they can count on that says this is a mistake. And it's okay if it's not every mistake, as long as it's really high confidence. They don't have time to go chasing stuff. And so part of this problem is the tool problem, that they're oversold. I'm sorry if I'm insulting some marketer here, but that is my experience. They're oversold, and they don't cover the complete problem. So you have to have a bunch of different verification pieces that kind of overlap and back each other up. You know, you're seeing me, I'm doing this behind, but I'll do this up in front of the camera. Little bit overlap, little bit backing up, so that I try to cover as much of the problem as possible, different approaches. And that's expensive. And we see that. If you go look at the BSIM is not a scientific survey. It's companies who are leaders in terms of investment who can afford a BSIM. And so you're looking at what leaders do. And even there, you'll see that there are points where it's more mature and points, the maturity rating is very good in my opinion. They've spent a lot of time on that. I am very impressed, incredible science. But you see in the spider graph that there are points where people are more mature and nobody's at all the way at 5, believe me. But more mature and areas where we're weaker. One of our weakest, and you brought it up, Jim, and you brought it up on Mal, and that is around secure design. That still is a problem, is that we can't get early enough and we can't get enough to really get in there and get our requirements up so that we know what we want to build, and then allow that to change, because we have agile, most everybody's agile today, or pretend agile, or whatever you want to. Agile partisans can argue about this, but I'm not interested in that. But nevertheless, a lot of people are trying to do things, you know, where they can do things iteratively. And so I don't know if I'm answering your question, and I'm kind of spinning now, James, but
that's fine.
I think that's another piece of the puzzle.
Can I jump in?
Go, Jim.
No, Brooke, you said a few things that are really important. I just want to emphasize, like you talked about how the limits of tools in the application security space. We depend upon DAST, SAST, SCA, and IAST, right? Dynamic scanners, static analysis scanners, software composition scanners. And if we really have extra money to burn for low results, we buy an IAST or RAST tool, because they're not that valuable in my opinion. So now, as a little smack talk, please forgive me. The point I'm trying to make is the limit of DevOps is saying, here's what DevOps says: when a developer checks in code, run a bunch of automated scanners before they can go live. That's great. And it's highly limited. The application security scanning tool space is not doing a good job of being thorough, even with overlapping tools. Because scanning for security bugs is brutally hard, number one. And number two, there are a host of business logic, access control, and other issues that tools don't find. Do you think they were scanning Exchange's source code? Yes. What kind of scanner were they probably using, Brooke? What you know what Exchange is written in, Brooke? It's like what, C++, right?
Yeah. Oh, yeah. It's
so they're probably using C++ scanners that find things like buffer overflows and all the C++ issues. Guess what they didn't find? They didn't find server-side request forgery, which is traditionally a web security issue that is suddenly a problem with an Exchange. So, I mean, and Microsoft is probably using the best of breed C++ scanning tools, and a web class bug popped Exchange. So I'm just saying that the problem with DevOps is over-reliance on security scanning tools to be the sole arbiter for software security. We still need manual experts to do manual code review and pen testing if we can afford it. But we're moving so fast, nobody wants to do that anymore. They want to just slap into DevOps and just run a bunch of scanners and woohoo, we're doing security. And it doesn't work that way at all. And yet that's the trend. That's another danger of the trend that we see. That's all I want to say. I really agree with everything else you said.
Hey, Mal,
Yeah,
I was
going to add.
Yeah.
Just add to something what Brooke was saying, right? It's very important, right? Because what he's saying is, he talked about, computer science and Turing, Turing model, Turing machine. I'll take a slightly different way to say the same thing. Makes sense. If you take one tool and integrate into 10 products, you have 10 integrations, right? And if you take 15 tools and integrate, the number increases. And any mathematical model will tell you that if you increase the variables at some point, mishaps will happen. It doesn't matter. You can have best of the breed scanning tool. So mathematically, what mathematics is telling us, modeling is telling us, just by having the environment we do, you're introducing all this stuff, which to Jim's point gets missed even by the best scanners, because that's not really how you solve this problem.
One more very brief note. There are a lot of vendors in the application security space who are saying, buy my one tool and we'll solve your security problems when it comes to software development. This is the kind of vendor you ask to leave the building, because no vendor I know a lot of vendors who will tell you to use a variety of tools together. I mean, most vendors these days get it and they'll tell you that. if any vendor, this is a good a good alert to have in your vendor procurement process. If a vendor comes in and says, buy my extraordinarily expensive tool and wire this into your products and do testing with our one super expensive tool, and you don't need the others because they're all bad, they are flat out lying to you, and they know that they're lying to you. So to have any chance of getting DevOps done correctly, especially for these big software teams, you need an assortment of tools that usually land in the SAST, DAST, and SCA space, plus need to leave room in your budget to have an expert come in and review your stuff manually. And this is only testing. We haven't even got started talking about working with developers to build software security in a proactive way. All right, that's it.
So Anmol, this whole discussion, all three of you kind of really got into the fact that it's apparent that a vast majority of programs choose not to invest in vetted, supported, and secure implementations, and that they prefer expensive and hard to tune tools. Do the three of you feel that you guys have really addressed why that is before we move on to the next topic?
Can I throw in, because this comes from our friend Petter Pedersen, which we knew from the BSIM days.
Yeah.
We were looking at the spider graph from BSIM, and again, I want to be careful of what that measures, but we were looking at it, and he suggested there's a poke out at testing and policy, and he suggested, you get your new job as a CISO, and he was a CISO, and you got to prove in your first 100 days and your first year that you're doing something. It's real hard to do something with, let's call it security architecture or requirements or design or building a satellite program with your developers, all these things that we're touching on but not describing yet, but which James talked about at the very beginning. That's really, to me, critical. If you're not working with developers, wasn't that you who on Mal said that 75% of the time you're not doing software security, or was that you, Jim? Whatever.
Okay.
Truism, total truism. Okay, so this is not getting at it, but the point here is I got to show the board I'm doing something. Well, if you buy a new tool and you put it in and you can pull it to a pile of vulnerabilities, doesn't matter whether they have any risk in them or not, but you can point to your increasing pile of found vulnerabilities, or you rewrite the policy, or you do both, instead of taking the long journey of software security as a holistic process. I think that's part of the problem. I think part of the problem is that we're afraid to take the long journey, or it's just a business imperative. I've got to show that I'm doing something and making things better, or I'll lose my job and somebody else will get it. I think there's some business imperatives here at the very top. Go, Jim.
Brooke, no, but there are let's talk about the positive. There are real ways to demonstrate that. If you're a manager and you have to show like the board or C-level staff what kind of progress you've made, then you need to actually track your data. I know a lot of programs where they run scanners, they fix bugs. Then I ask them, well, what have your trends been the last 2 years? And their answer is, we have no idea. We throw those reports away. So I think one of the most important things you can do is not like slapping a new tool, but use one of the vendors that track vulnerability data. Like there's Josh Sokol has a program called Simple Risk. There's ThreadFix from Dan Cornell's company. There's Kenna, which has got a lot of funding. My preference is to use a company called Nucleus Security, Go Nucleus. Either whatever one you use, all these products will let you feed vulnerability data from a variety of products into this content management system, so you can actually track vulnerabilities over time, so you can measure if you're doing better. And that's the whole point. If you want to talk to your boss about what you're doing, you can't change what you can't measure. So to be able to track this data rigorously, and not some like bullshit Excel spreadsheet, pardon my language, but rigorously from a plethora of tools feeding into a application or vulnerability tracking system, then there's really no way to demonstrate to your boss real progress. Just because you're using a tool. I mean, I know a lot of the early generation static analysis tools that people bought for millions of dollars. They got the checkbox next to it. Then they put it on the shelf. And this is a very expensive product. It'd be rude of me to mention the name Fortify, but I'm not. And and I don't mean to attack Fortify. They've changed as a company, but Fortify was the big player in static analysis for a decade. And the vast majority of companies who bought it, they barely used it for what it could do. And that's nonsense. That's absolutely nonsense. So if you're going to buy these expensive tools, and you got to, number one, actually use them. And number two, feed the data from these tools into a real tracking system. And guess what? Now you have real data to like show to your boss. But more than that, you have real data to measure if everything that you're doing is getting better. Is your training programming work? Is that WAF actually working? Is these tools I'm running working? I'm like, is the turnover, how is the turnover affecting security? If you track this data carefully, you can actually measure it. And that's an aspect of BSIM to do this. And a lot of companies don't.
Anmol, anything to
Yeah,
add?
I wanted to add, what Jim said, if you buy expensive tools, make sure you use them. But in my experience in the industry, that of course is a problem. And I don't want us all to just think that the issues in the space or the tooling space is because of the vendors, right? You have to look at external factors. You have to look at the easy monetary policy from the Federal Reserve and the market at large. So that drives some of the external variables, but internally, I think we talked about what drives it. As far as having these tools and then getting the data, I feel a lot of times there's too much of it, right? There's this madness of just measuring everything to the next level. And Homo sapiens are not wired to understand risk. We don't understand probability that well. We don't understand risk that well, especially not if you're out of school for 2 years and think you are an abstract, genius, for example there, right? I think that hits to the heart of the problem, because what happens is you have the tools, you have all these other challenges we have. It boils down to how do we communicate this to the stakeholders in the company that you're part of in a way that makes sense. And that's where the risk, the probability, and how you measure what you measure consistently over a period of time in a language that everyone understands is important. And again, tools only will give you more data if you just do some of the things Jim has mentioned. Testing, some of the traditional design activities, you'll get the best bang for your buck rather than giving 10 tools and that much output, which you will then need to spend time. Mind you, you'll need a team to actually do all that work, which again, I would then question if you had to do a new process to make this tool work in your company, and you then have to build a 10-people team and a 24/7 ops. I would then ask you, why wouldn't you take that money and put it in let me hire some senior software engineers who are great at writing code, and then let's take 5 things. Identity is one space, so you can look at trust boundaries around authorization, authentication. Then you can take a crypto and look at that, and then you look at some of the sensitive areas and do the manual code review. I think that's really where the focus should be, and not so much the tools as we see them.
I still think tools are important. I mean, it's like if I want static analysis, and I can get a lot of stuff for free. Like my tool chain these days is, if I want to do static analysis, I'll use SemGrep. It's not open source, but it's free, and I can run it in 60 seconds. Unlike every other static analysis tool in the market, I can run SemGrep's SEMGREP. I can run the whole suite of tools for free across my entire enterprise with a wide variety of languages, and it runs in DevOps speed, number one. Number two, if I want software composition analysis, I'll go get OAuth dependency check run by Jeremy Long. He uses it for Wells Fargo. If I want dynamic scanning, I'll go use Zap or even spend the money and get Burp. They're both great tools. So I can get a really professional application security tool chain wired into like GitHub or Jenkins almost for free. And so I don't want to dismiss tools. They're an important portion of application security. And the thing is, one of the things that make me optimistic is I can go to GitHub and go, GitHub, new repository, pay like $50 and wire in Dependabot, static analysis, and dynamic analysis, click, 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 and I'm done and I'm live. And we used to spend 6 or 7 figures to get The Citilians and other consultants do that for us. Not anymore. Click, 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 spun up, and it's really world-class. So there is hope. Absolutely, there's hope. Here's another thing. Design, you think that design review is the best bang for the buck? I think that's a BS statement. I have watched so many major consultant shops do these elaborate design threat modeling exercises for weeks and spend tons of our time, and I get a threat matrix out of it that's rarely actionable. So I know that you and Brooke and James are a part of really good threat modeling exercises, but I've been through so many threat modeling exercises that were theoretical, that didn't give me actionable results, and then we spend hours.
There's a spoof.
And then we spend hours.
There's a spoof.
We spend hours talking about whether or not to fix SQL injection or not.
Yes.
Don't talk about SQL injection. Fix it. Don't talk about it. Don't threat model it. Go fix your bugs. Fix your bugs. And let's use threat modeling for things that are
Jim, why are we talking about SQL injection or any of these web things? They can be automated. We know about them. That shouldn't be part of your threat modeling. Doesn't require human analysis anymore.
I agree. I agree.
That any security architect worth their salt wants to keep talking about cross-site scripting year after year, review after review, when there are threat modeling tools that'll tell you about that. Even TMT will tell you that one. The Microsoft threat modeling tool, it's free to a good home. Yeah, no, why are we doing that? I'd rather spend my time working on the really hard problems.
Yes.
Like, here's one for you all to think about. A legacy system that was built in 2002. So at that time, a secret account key was just fine because nobody was thinking about that stuff in 2002. Nobody. That wasn't part of the threat landscape. Okay. The thing is now the business is relying on it for millions of dollars, and they still have that secret account key, which must be compromised in a bunch of the customers already long since, right? And that's the kind of problem I want to address, because it's got to be changed, and it's going to have to be iterative, and you're going to have to work on it, and you're going to have to think about, how do I keep this thing alive so we don't lose our millions of dollars while I move this thing to actual authentication and authorization that we can support, that can't be hacked. That's the kind of problem. And I didn't make this up, by the way. That was a real world example.
I'm with you.
A real thing. And that's the kind of problem I want to spend.
The legacy problem is easy to solve, Brooke. Blood, sweat, and tears. It's expensive. It's expensive. It's painfully expensive. There's no shortcut. If you have legacy software that has major security problems and you haven't dealt with it for 20 years, you have to pay the piper. You have to spend money and time, and you're going to pay for that. Ignoring security for 20 years, shame on you. You're going to pay for that. And by the way, Anmol, I know you're a good threat modeler. I know Brooke is a good threat modeler. I'm not pointing the finger at you at all. I know you really know your stuff. I'm talking about the threat modeling industry in general is a big waste of my time. And there's a very small number of threat model thinkers I think who really get it. Avi Duglin, Adam Shostak, James, yourself, and a handful of people who do threat modeling well. That's right, Sheriff. And I think most threat modelers waste my time. But legacy, good luck. Bleed, sweat, cry, pray, throw millions at it, and you deserve to spend those millions. There's no shortcut to mammothly insecure legacy software that you depend upon. And good luck. Go ahead, give me a shortcut. And I don't think it's real at all.
All right, gentlemen. I think we've had an awesome discussion on that topic. Let's move on to another one. I think people get that one loud and clear, literally. So let's move on. Let's talk about what are the challenges with third-party libraries, open source, and APIs in relationship to software security? And what are you doing to address these challenges? And most importantly, do you believe this will get worse as the cloud adoption grows? I'll start with you.
Yeah, the answer to the last one is easy. I think it will get worse before it gets better as cloud adoption grows. And I think how do we solve it? I think we'll come to that towards the end. So that's the cloud. And I'll go back to what's code question again. Yes, we can have these. Of course, there's a space for tools all kind of tools in the software security space. But today, a lot of code, large percentage of code is open source, right? And so how it just depends on how we are even accounting for what software security should look at. We need to get our priorities right. If I had to pick, I would make very specific. I would put very specific areas to do threat modeling, very specific design in an iterative way, like Brooke would do, and then really focus it on the integration libraries, third-party open source libraries, and get a handle on those. That's where some of the largest risk can come as the reusable frameworks and components becomes the norm in the future.
Great, thanks. Brooke, over to you.
Well, so, and I didn't mention this when I talked about holistic software security, but obviously I believe that because so much of our stuff is written on top of other people's code, the other people's code is also part of our software security, and you can't ignore that problem. You can't just throw it away and say, oh, that's somebody else's problem. I'm a big fan of stopping, grab, and go. That has been the story in most shops for a long time, where developers are allowed to grab whatever they want and use it because that seemed like the best library, or I'm familiar with it, or whatever. We have to give people something, though. You can't expect every developer to become a software security assessor either. So there's a little like trade-off problem that I've wrestled with for a long time. How do we help the developer make good choices? And the way not to do this is to create some manual board of experts who sit and pass judgment on every. You want to kill agility and all nimbleness? Do that. And a very large tech company we shall not name did exactly that, and it was painful beyond painful to go to this board. 6 weeks you had to wait to get up. I mean, by then people are off doing something else. I mean, it was ridiculous. Okay, so I'm not a big fan of that, but you got to give people some tools, and there are some interesting tools out there. They're kind of expensive, but somehow we have to help people understand that you have to assess whether there's a community, especially in open source. Is there a community capable of fixing bugs and interested in fixing bugs? That's the first problem. If there's a community, and I got taught this by some really great open source people, you got to have a viable community. If it's 3 people, that's fine, as long as it's viable. But if I had a choice between 2 relatively equal packages, the one that was built by one person who hasn't looked at the code for 5 years, and one that has a viable community, I'm going to go with a viable community every time, because at least they can fix the bugs and will hopefully fix the bugs that come up. Okay, so that's a piece of the problem. Are they using static analysis? There is no reason that open source projects shouldn't be at least doing static analysis. And I know that's not a panacea, but there's no reason, because a couple of the vendors give it away free to open source, and then there's SimGrep, there's Clang, there's lots of solutions out there. There's no reason they shouldn't be using that on there at the very least. So I'm going to look at a couple of those things, and those things are pretty easy to find out, by the way. So a little investigation, give your developers a little help here, and I'm being really specific to give you actionable stuff that can choose better. I don't want to stop them from nimbleness and agility. I don't want to stop them from being able to work iteratively and move fast, but you got to give them some stuff, or you buy one of those expensive tools that purports to do this for you. And I'm not going to name any names, and I'm not going to say anybody's better than anybody else. There's a few entrants into this problem, but you got to do something. Okay, having done that, now what developers often don't realize, and also product managers really fail on this one. So security folks, get out there and remind them, a inclusion of somebody else's software is a deal for the life of the software with vulnerability management. You're trading today's development for tomorrow's vulnerability management and security. This is very important. It's a contract into the future. And if you don't understand that, and a lot of times people don't, it seems like, well, we're getting development for free. Good, let's go. But you're making a deal into the future with that product to pay attention. So that brings us to vulnerability management. Now we got vulnerability management. It's a fire hose of vulnerabilities. How do we know what to do? Can I take that piece of the problem, and maybe Anmol or Jim have a great solution around this, but I have a couple of things that I've been cooking on, a couple of things we've done that I think work, and there's a couple of paths that I think work, but I don't want to go on forever with this. Let me come back to that. Maybe that'll be a good question and answer. How do you handle the fire hose of vulnerabilities? But you're going to have a fire hose of vulnerabilities, and you're going to have to deal with it for the life of that. While that piece of software is included, you have to deal with that. That's your contract with the future. So I think once I got the last couple of project, teams I've had, once they got that message, it really helped, because most developers I've worked with, the vast majority want to do the right thing. And once they understand what the right thing is and they can get it, then I got them on my side. It's not that hard. It's not like we're fighting, against each other. If you do it well, it's like we're working together. So once I get people on my side, then it helps. And I'll just give you a little hint here, getting to product management, if you have such a function at your companies, or enterprise architecture. So you get in early and also get them on board with this idea that vulnerability that you're making a contract, that will help. Little hint.
Jim.
I would add one more thing, James, because I think this one is important in itself. Just like we talked about, making a contract with the future by using someone else's code. But in this problem sort of lies the solution. And I'm sure Jim and Brooke would agree. If we spend our time building frameworks that are consumable by developers, we can eliminate the entire class of security issues, right? So instead of attacking, and I know we are about to go to one management, but one management to me is more instantiation of the same problem, right? And so if you can tackle that framework, whether it's input validation or the other things that you want to make sure you do as part of software security, we can use this behavior of developers and humans in general to drive a different kind of adoption, and that's one of the solutions that you can have in your armor going forward.
Great, thank you. Jim, anything to add?
I do, actually. Third-party libraries is probably the biggest problem in modern software security, and there's no good solution. Let's go through the trade-offs here, right? So one thing we can do is we can say, well, let's limit developers from using third-party libraries. I think we should be doing that, but you're going to slow development down and you're going to harm existing projects. And so number one, I think that's the problem is a lot of developers grab and go, like Brooke said. I'm going to steal that, Brooke. They grab an open source library, push it live, and they're good to go. That's nonsense. We need to have more judicious behavior and some vetting before we let a developer pick a third-party library. And if that vetting process is 6 weeks, you're going to shut down development. So there's not a great answer there. We can train developers to vet on their own, but that has limits as well. There needs to be some kind of vetting. I don't know from a scientific point of view how to really do good vetting. We want to look at, is it active? When was the last update? Do they have a security group? Are there existing CVEs or NVD entries for that library from its security history? That's some things we know how to do, but it's difficult to do that at scale. All right, number two, let's run a class of security tools called SCA, Software Composition Analysis, to see if we have third-party libraries that have bugs in them. Now, that's great. The vendors out there are astronomically expensive, and I would not be spending money on the White Sources or Sneaks of the world or JFrogs, and I'm not afraid to name names. These are great products, but they're crazy expensive. I would rather to see you use an open source tool like the OWASP dependency check, which I just put in chat. This is a great way to get started. It will give you some actionable results to find the third-party libraries you're using that have real insecurity in a free way. And then when your application is totally clean from insecure third-party libraries, the next step is to keep all your libraries up to date. is to go out of your way to not just fix a third-party library when there's a security bug, but to keep them up to date at all times. And that requires a lot of discipline. I mean, you're going to have conflicts when you do that your developers need to know how to resolve. But the issue is we don't just want to update when there's a security problem. We typically want to update a lot more frequently because there's many security bugs that are in third-party libraries that don't get published and similar. And if you do, and here's the other problem, if you do that, if you keep all your libraries up to date, then guess what? You're going to introduce problems from the software third-party library ecosystem where backdoors and similar are being entered into that world. And those problems are becoming more frequent. Well, how about this? What if a developer types in the library? What if, I didn't mean to go to Sean. Sorry, Sean. Push that live, Sean. So I meant to send this to everyone. That's the library I'm talking about, dependency check. That's a great way to start. But the problem is if you keep everything up to date all the way, you're going to have problems with malware from the third-party library ecosystem, which is becoming more of a problem. The other problem is if I'm a developer and I'm typing in a third-party library and I misspell it by one letter, there are those that are typo squatting on those misspelled third-party libraries to introduce malware into the ecosystem. So what am I going to do? No matter what you do around third-party libraries, you're screwed today. And the thing is, even if you go with one of the big commercial, one of the reasons I do like the Sneaks and the White Sources of the world, their libraries of vulnerability data is a lot better than the open source world. They tend to be 30 days ahead of everyone else. Like NPM Audit, they missed a problem with DOM Purify, a really critical JavaScript security library, and NPM's a JavaScript repository. Sneak, they picked it up right away. It was in their product, where NPM, the curator of the JavaScript ecosystem, took them 30 days to pick it up. So when you're already on top of everything, and your third-party libraries are already up to date, and now you want to be fast in terms of seeing that vulnerability data because you are taking action right away, that's the only situation where I think you should be spending money on the sneaks out there. Otherwise, go open source. And no matter what decision you go for, no matter what choice you take, the ecosystem of third-party libraries is a complete and utter shit show. And there is no good solution today. And I think it's the #1 problem in software. I'm going to show you one more thing here, I think, to finish up this. So I'm going to go to XKCD, and I'm going to look at dependencies. This is the problem of our whole industry that no one wants to talk about. And none of the products and vendors in the industry right now are even close to sharing. Go take a look at this cartoon from XKCD. And this is the truth about dependencies. And what the picture shows is this giant castle of blocks. And near the bottom is this one little block holding everything up. It's a project some random person in Nebraska has been thanklessly maintaining since 2003 with big security bugs, and our whole world depends on that. So we've built this castle made of sand to some degree when it comes to third-party libraries. And I go out of my way not to use them anymore and to try to simplify my design. Nobody wants to hear this, but there is no good answer to that problem.
You know, Jim,
we are screwed. We're screwed, Brooke. It's over, Brooke.
Great thing. Why do people not invest in creating vetted libraries? You know, Christoph Kern at Google Apps got rid of cross-site scripting by building a library that everybody has to use. They invested in building a library. And not only that, the great thing about building a vetted implementation is you got one place to fix a bug. You all know this. You're all developers, or a lot of you are developers. You know, I'd rather have one place, one routine where I can fix the bug than have that spread out, you know, over hundreds of thousands of lines of code. It's much better. It's much cleaner. So you said it, Anmol. I want to underline that. I don't know why people are not investing in building, but I find it very rare. It's actually quite rare.
Every vendor that came out with the list of vetted, approved third-party libraries, their product offering failed because developers don't want to use it. They want to use whatever they want to use, and companies rarely stop them from doing it. So now the whole world software infrastructure is built on top of this random project from Nebraska that has security bugs in it. And this is a problem that's not going to go away for a generation.
I'm sure there are
We're
great
screwed,
programs.
Brooke. No,
in
it's
Nebraska,
over,
by
Brooke.
the way.
It's over.
All right, another one. I think we've beaten that one to death. So let's move on to the next topic. So how are you addressing the challenges of microservices and containers with regards to software security? And are the technical challenges with microservices worth the complexity? Let's start with you, Jim. I know you got a passion on this one.
Mike, I love microservice architectures, but it's a lot more difficult to build them. But if you combine microservice and Kubernetes and have each microservice in a separate pod, all the magic of auto scaling and all this fancy stuff, it is dramatic. But a lot of people use these technologies without needing to. So unless you really need to break up your software into hundreds of different services and have them scale individually, go monolith. There's still a great need to use monolithic APIs. Back to microservices, the big change in microservices is the move away from standard session-based authentication to stateless authentication and session management using a technology called JSON Web Tokens. And as soon as you get into JSON Web Tokens, you now get into key management, digital signature verification, and all the complexity with the PKI. And the point is, moving to microservices, most people do it when they shouldn't be, and they don't need the complexity of that architecture. And those that do it and really need auto scaling and similar on a service by service basis, they got to get ready for the big expense of key management and using a key vault and key rotation and handling revocation and all the things that make microservices much more difficult than traditional monolithic architectures. And there's a need for it, for like Netflix is a big player in that arena. They need microservices because of the scale that they're under. But when you're a little tiny company is doing this giant microservice architecture for no reason, you're using the wrong architecture for the wrong problem. So be careful.
Anmol.
Sure. I'll take a slightly different view here. I think depending on the end use cases that Jim mentioned, right? If you're Netflix, in many design cases, it makes sense to use microservices. And I'll go back to what I was saying earlier, for just like we can have frameworks and libraries solve for entire class of security issues by using the new paradigm of cloud, right? You're really securing your code at the check-in and then really having a more of an immutable pipeline in the integration and deployment phase. If you can get that right, then I think microservices give you more bang for your buck, because then you can allow for the trusted boundaries. You'll be able to define those better, right, and get handle on more agile. So there are benefits of doing it. It depends on which company you are at, what's your maturity, and what kind of support you have. So that's a lot of what I see.
Sure.
I have no dog in this race, to be honest. I'm one of the problems in my life as an architect is I'm often given an architecture and don't get to comment on it a lot, and then I have to try and figure it out and secure it. So if it's a microservice architecture, okay, I got to understand that, and I think Jim laid out the problems very well. It can solve some problems really well, and it can create some problems. So I don't really have a strong opinion one way or another. It's another way to solve problems, and if you need to break things up into really small pieces, maybe that's a good idea. On the other hand, some very successful products like PayPal were monolithic for a really long time.
Well, let me.
I would add one more.
Go ahead.
Just one more thing, right? Some of this debate reminds me of when I was in my grad school, and monolithic kernels and microkernels, right? There is a cost, but most kernels are monolithic. So those design decisions are depending on, should be made depending on who the end user is and the use cases are. But given that we end up with microservices architecture, I think there is a goodness if we can get that right first couple of times, because then it just gets better in terms of giving you a return over a period of time.
Thank you for that. Brooke, I'm going to come back to you now because there's one I know that you'll definitely have an opinion on. Kind of touched a nerve earlier, but I think we should vet this one out a bit. Can we test our way out of design time work? And can secure design be automated?
Well, no, we can't test our way out of design work, but that doesn't mean that they're not related. The way I think of it is we do our best with design, and design is an iterative process. The great threat model, Jim said this before, but the big threat model that comes in, after the design is completely baked and finds everything that the security people think are done badly, it's a killer in so many ways, and it destroys the esprit de corps, the morale of the people who spent, probably weeks designing something. It's really bad. I'm really against point in time threat modeling.
Did you give us some French there? What did you say, Brooke?
I really don't like point in time threat modeling, even though I get paid a lot to do point in time threat modeling. So I like the money, but I really don't like it. What I much prefer is threat modeling is the foundational technique for helping to figure out what we want to put in for security. It's what us security architects offer to the general design, but you can't be a security architect unless you're an architect, unless you can design, okay? You just don't get to put that up on your name and say, okay, I know about a few attacks and defenses. If you can't do design, really, you're not an architect. So, it's a foundational technique. That's all it is. And we return to it again and again and again. So should we automate some of that? No, let me talk about testing first. Testing is the way we prove that our threat model is correct as far as we know at any particular time. There's a feedback loop. If you're not paying attention, and this is classic DevOps, by the way, is the idea that everything is revolving. All these different processes are revolving sort of continuously or almost continuously around our communication and our feedback loops. So that's the way I think of DevOps, and I want to think of them as continuous processes. So rather than discrete phases, because that discrete phases are gone in a lot of shops. Nevertheless, I want to know if my threat modeling assumptions or what I thought was the right thing to do is disproven or proven by the testing. I need to know that, because the threat model's living. It's something that's moving all the time as we change the software. So it can't just be a point in time. I'm really against point in time threat modeling, even though, as I say, I get paid a lot, very nice money for doing point in time threat models by companies. But nevertheless, it's not my favorite. It's not my favorite approach. Nevertheless, it should just be foundational. And that's why I think we want to train, at least introduce just about everybody who does development, who's involved in development, at least introduce threat modeling. And there's some, and come back to this, James, later on, there's some really wonderful benefits of that have nothing to do with threat modeling, but which have a lot to do with software security. Okay, so that's kind of my position. Can we automate some of it? Testing is very important because that proves or disproves my ideas, because I could be wrong. I have been wrong plenty of times in my life. I am an imperfect analyst. And finally, the piece here is that we can automate some of this. Today's threat modeling tools are really getting to be mature. There's only a couple of commercial entrants, and I don't know what they cost. I will disclaimer that the founders of both the leaders in this arena are both dear friends of mine. And so, that's it. I have no interest in either company financially, so whatever. But nevertheless, you can automate some of this, and you should. In my opinion, you really should. You shouldn't be, again, I don't ever want to tell somebody they need to look for the OWASP top 10 in their in their web coding. That should be handled in a different way. And that should be obvious. And if it's not obvious, you can spin it out automatically every time you see a web input. Or get a vetted library and take care of it like Christoph Kern did. But nevertheless, there are other ways to handle that problem other than having a human analyst to do it. And the threat modeling is getting really quite mature. And I'm the automation. So I'm really keen on it. And I really encourage people who can afford it to get in there and do that. I'm not real encouraged by any of the open source threat modeling tools yet. Maybe the best one is PyTM, which is threat modeling as code, because it actually does a bunch of stuff. Some of the other ones, Threat Dragon, haven't seen it really produce anything except a drawing at this point. You got to put in your own threats. But TMT, threat modeling tool from Microsoft, will spit out a lot of stuff. You got to go over it, but it's free and it will spit out a lot of stuff. It'll get you started, which is not a bad thing. So, you know, there are ways to automate this that are open source and or free, and then there are tools. So, you know, I would encourage you to look into that space rather than, you know, you're not going to hire, as far as I know, an army of Anmal, Jim Manicos, and Brooke Schoenfields, or any of the other great threat modelers in the world. And there's quite a few. There's a few, but as Jim said, but you're not going to. But I do think you could automate some of this and reserve your human analysis for the problems that are hard and that are not easy for automation. That one thing will keep your keep your security architect down, at least trying to hire an army. We once tried to hire an army of security architects, Michelle Koblis and I, and we could not do it. We once tried to do this back in 2002 or 2003. And Michelle and I scratched our heads and said, you know what? We're going to have to get our satellite people to do this because we can't hire these people. And the world has not changed in that way. You can ask Michelle. She's part of this group. It's true stories. She and I sat in her office and scratched our heads and said, what are we going to do? We did. And you know, we came up with the satellite program. Took a couple of years to make it happen. And after a year of it happening, we had all the groups in Cisco IT coming to us and said, how did you do that? It's a true story. But nevertheless, you're not going to hire an army of, so you're going to have to train them and take the time and automate as much as possible. So I'm really keen on automating as much of this as you can. There is automation. It works.
Thanks, Brooke.
I'll give you.
Step in there a couple times.
Yeah, I take this as a challenge, and I do think this is where the solution lies. I'll take a slightly contrarian view. I think the way we'll eventually get handle on this is through automation and really using more of the advanced, techniques available to us. And so I do think, except for select things that the architect should do or the security engineer should focus on, most of this should be done as part of automation, either in the library sense, either through the other parts in the SDL pipeline, or after the fact.
Jim, anything else?
Give me the question. I was busy chatting up some comments.
We were talking about, can we test our way out of design time work, and can secure design be automated?
I'm gonna go with an answer in German. Nein. I'm done.
All right. What I wanted to do now is, Mike, I just wanted to talk with you real quick. Do you want to open this up for questions from the audience now, or do you want us to continue to go on?
You can go on as long as you'd like. This is awesome. So if you want to go another 20 minutes, I got another 20 minutes in me for sure. And if people want to continue to send me questions in the chat, we can do that then in a little bit. So that would be my take. So let's keep going for a bit.
Okay, we'll move on then. All right, great. So one thing, Anmal, you talked to me offline about quite a bit is you know, what are we going to do on the over the horizon stuff like artificial intelligence and machine learning issues? If AppSec doesn't understand code now, will they understand it when AI writes it rather than humans as it's done right now? What's your input on that?
I think that, thank you, James, but I think that was sort of my rhetorical point, I think, when we were talking about preparing for this panel. But I'll go back to what Brooke said, what Jim said, right? Essentially, what we need to do is get out of this never-ending race of thousands of issues, the tools, and then focus that, have a very focused approach of very select resources that we have. We don't expect army of people. So we then need to not only train them today so they understand code today, we need to then help them understand how machine learning models work, because the future is going to be models against models, you know, really nibbling at the data with the compute at scale with intelligence built in, right? I mean, that's the eventual, eventual landscape. And I think we need to do this favor to ourselves is train and educate people. So first they understand, how to write code. And if you are in infrastructure, then you figure out how to write infrastructure as code. And then we actually train them over the years to get the AI, because right now I don't see that happening. And that's frightening, because what that means is no one will understand models making decisions. And that's really where we need all the brain power and the neurons from the product security world firing in the future.
Yeah, well, there's a lot of snake oil out there when it comes to vendors claiming what they can do with AI and machine learning right now, that's for sure. But there's also some next gen stuff that looks real promising. Jim, any thoughts on that?
I tend to be skeptical of AI-based security because of a lot of times it's just statistical analysis. It's not real machine learning algorithms. That's one side of the token. The other side of the token is AI is not that big of a deal, right? The whole recent generation of Chinese computer scientists, they went through real elaborate AI programs, and good machine learning use is a natural tool that developers can use. But a lot of times I see American companies claim to do AI. We don't have the AI background that we see that other countries have. China is a generation ahead of us in this regard, and they are using real ML, and their products are showing it too. A lot of the US companies don't have that background, so they claim to be doing AI and ML when they're really doing statistical analysis, and that's a very different thing. The other thing is AI and ML is very flawed based on if you're feeding garbage in, you're going to get garbage out. We see all kinds of horrible racist things coming out of AI. Oh yes, you look at some of the machine learning in Los Angeles and how they're doing predictive policing. This is horrible. It's like when you have police originally going into areas of a certain kind of ethnicity, and then you feed that data into an ML to tell us where to police tomorrow. It's completely flawed from a lot of big ways. So we have a lot to learn about AI and ML before we're using it as an effective real world tool. And the US is a generation behind other countries. And so whenever a US company without people who have real good education in this area are saying stuff like, oh, we do AI, we do ML, and we can solve all your problems, I almost always call BS, almost always. And it concerns me. But I don't want to discount the whole technology. The current generation of software developers in school in the US are now learning ML and how to use it effectively. So I'm going to be really interested to hear what we see in 5 years out of US companies. But for now, I'm kind of skeptical.
Thanks, Jim.
And you touched on something important, Jim. I want to emphasize. Even today, we get into trouble in the product security area because of the quality of data, right? So if you feed in a biased or incorrect, models, whether it's design models or the code, essentially the machine learning models, if they are real ML models, not the hype created by the vendors, they then pick up the wrong biases, and that actually over a period of time magnifies, right? It increases exponentially, and that problem also at some point will fall under how to solve within the product security design world. But that's a very important point. The quality of data is the single, probably most important indicator of outcome you will get from artificial intelligence. If you don't have good data, you can throw the best compute in the world, your calculations will be completely off the base.
Very well. That's really well said.
Yes, very important.
What are your
It has to be the data. So just so everybody knows, and James and I were involved in a bunch of ML based security product. Not all of it is smoke and mirrors. Some companies have actually invested in real data scientists and real ML, and they are using it, and they have lots of data. So some of this is real. I don't know when we're going to see AI or ML actually write code, to Amol's point. I don't know. I wouldn't be surprised in the future, but so far, all the ML I know of and all the AI I know of was written by human beings. So, you know, it's something to think about. I don't think we're there as far as I know. I will point out the BEML stuff, which is what Gary McGraw is doing right now with a bunch of other people. And it's fantastic. If you want to know about ML security, go look at the BEML stuff. And Ponemon Institute for Machine Learning. I think that's BIML. And their reports are really top notch. It's really great stuff. So if you want to know about ML security, I suggest you start at the BEML stuff. And there was a really good book. Is it AI for or ML for Dummies? I think that it's not one of the dummies things, but or for regular people or something like that. That book, I haven't read it, but I've heard it's very, very good. So there's a lot of work going on in this area. I agree with Jim. I have seen a lot of smoke and mirrors, but then, you know, when you walk around at RSA and you see sign after sign that says solves your security problem and it's some point product, security marketing, I'm sorry, Max, if I'm insulting you or any of the other sales folk here, but you know, if you and it's Max has never said this to me, never. But if, for people who do say solves security, and neither has Mike to me ever, which is why they're my friends. But you know, if you see something that says solve security, you already should look for smoke and mirrors, because what does that mean?
Don't blame, you know, don't blame salespeople for bad marketing. Marketing hands salespeople the message, and they do their best with it. Blame who needs to be blamed. Marketing, and don't blame salespeople for preaching the message they're told to preach. And the point, and you're proving my point. I think that McGraw is like investing real money in ML research. So he's an example of like the first big wave of American research that's doing it right, in my opinion. I love the Berryville Institute of Machine Learning. This is really legit. I don't think the commercial space, actual firewalls and similar, are really benefiting from ML in the US yet. And that's the point I'm making. I don't see it in the commercial space. Please prove me wrong, anybody. But I think that the research that the US is doing, the current generation of education and foundations like Gary is helping fund, oh, those are really legit. I remember watching Gary just a few months ago. He's like, look what I'm reading. He's like, you know, 50 white papers on ML before him, because he's a real PhD and really has a studious background. So I'm curious if you see that in the commercial space at all, Brooke.
Well, the thing is that I was involved with some people with real data scientists who really understand this, who are building real ML for real products. So so I believe them. And an old friend of Michelle's and I's from Cisco days started a company where he hired a bunch of actual PhD folks too. But I also think there's a lot of smoke and mirrors, because it's the hype word. You use ML, you use AI, and they're just statistical analysis, or they're heuristic or something else, and it's not real. So you got to be careful. And
I have yet to see a commercial product that beats traditional products because of ML. In this, in the security space, I have yet to see a commercial product that defeats the capability of a traditional product because of some magic ML. And I know it's going to happen. I just haven't seen it yet. And I'm curious to be proven wrong.
Yeah, I'm not going to go there because, and sorry, Anmal, I'm not going to go there because I haven't done the work to really assess And I, like I said, I was involved, so I have trust that these people knew what they were doing and they weren't bullshitting. Excuse my language, but that's a different thing than actually assessing the quality of products.
Yes.
That's a very different thing.
Anmol, you had something else. I think you're on mute.
Okay, thank you, James. I was just going to add to what Jim was saying and what Brooke was saying. I don't see that much, and as a researcher, right, I'm not talking about tools and companies specifically. I don't see that mainstream. I do see one place where, as I'm doing my research, and that's on Wall Street. I see financial institutions really paying and going all guns blazing, and I'll encourage you to go and look at the openings at Goldman Sachs right now, and look at even companies like McKinsey are starting to play into this space. And remember, these are the companies where you'll have money, and as more of these sovereign funds come in, I think at least they will start leading it. How the commercial space shapes up to be, that's to be seen.
One question I have for all three of you is, we've talked about a lot of different tools, or alluded to a lot of different tools, and there's been a lot of chat. Some of it I've missed, but are any of you using fuzzing? And if you're using fuzzing, are you using it throughout the SDL? There's a big move from some of the next gen fuzzers to have it embedded in the SDL throughout the process. Are you guys believers in that? Don't believe it? And if you do use it, where are you using it? And if you're not using it, why not?
I'll go. My experience here, and this is based on our work together, James, is that until recently, fuzzing was too difficult for many developers to develop the skills because it took too long. I love fuzzing. You know, I've put it in the last two books that Anmol, you and I have written, and I'm a big fan. But my problem is it's been too hard for developers to learn. But looking at some of the products as they've matured and some of the open source stuff, and it's getting easier, which is, I'm hopeful. I'm deeply hopeful that fuzzing may start to be in the realm of, I can just put it in my DevOps chain and do it. And if that would happen, I would be very, very happy, because it's a great complement to the other kinds of testing strategies. And I'll note that your adversaries are fuzzing your code. Your adversaries are already doing it. And so, you know, if you're going to get your bugs before they do, you got to do the same thing. But unfortunately, it's been hard, you know, until fairly recently. And I'm hopeful. So that's all I got to say about fuzzing.
Thanks,
but
Brooke.
yes, fuzz.
Jim or Anmol, any comments on that?
I echo what Brooke said. I think in practice, that's where it falls apart. You know, fuzzing has a very important place in the tool chain. It's how we have been able to make it work with developers, and then the overall impact of that in terms of return on investment. That's something that I haven't seen, except for mature security programs. They do have it, and they do well as one of the tools in the arsenal.
Thanks. Jim, any closing thoughts on that?
It depends what you mean by the term fuzzing. Like, I would consider most DAS scanners to be a web fuzzer, and they're super effective for what they do. So if you think of fuzzing as traditional, like product level fuzzing, kind of throwing a lot of random stuff at it, then it's not even a part of my world at all. We don't do traditional fuzzing in the web industry, web security industry at all. Right. But I would call many of our tools fuzzers, and that are like DAS is a fuzzer in my mind, and it's super effective. Exactly.
That gets into kind of like the religion around application or software security, which is it. But when you look at tools like that on the web, you're really actually doing fuzzing when you're doing that anyway. So.
And these name debates of application versus software security, exactly, or DevOps versus DevSecOps, I tend to not think of those as meaningful conversations, because I care about the concepts underneath it. I'm going to quote, what did Shakespeare say? He said, "A rose by any other name would still be just as sweet." So I'd rather debate the principles of software security and the principles of application security, the principles of DevSecOps, than trying to change the name or make the name wrong. It doesn't matter as much. Yeah, the concepts are what matter.
Exactly. Well said. So lastly, what are all your hopes, and for each one of you, what are your hopes and predictions for the next decade in the software security space? What would you like to see in a perfect world? What do you think needs to be changed?
I did not expect, I'll go first if you don't mind. I did not expect things to get so bad. I really thought we'd have more progress by now. But all I can say is we have to keep charging. We have to keep trying to get better. We have to keep influencing developers, maturing better tools, maturing our processes. And my belief that when it will really get better, when the open source ecosystem and the languages themselves and the frameworks we're using begin to get more secure, we're going to have a much better chance. Like when it comes to building user interfaces, there's a Google product called Angular, which is one of the most secure user interface frameworks in modern history. And that's the exception and not the norm. When the depth of the Angular security in the third-party ecosystem is the norm and not the exception, that's when we'll hit a corner and start to have radical improvement in this area. I don't think anything else will get us there except for that indicator.
Got it. Brooke, Anmol?
I'll go. I think in the short term, we will continue to see, progress in terms of product security as a discipline. It won't solve the problem. You'll see more attention, more budgets coming in because of what's just going around. We talked about tools quite a bit. I see consolidations coming in M&As through M&A. As the interest rates spike up, I think you'll see vendors buying each other, and you'll see platforms approach in the tools themselves. So you'll see that work out. So keep an eye out on them. But I'll go back to what I was saying earlier. We'll double down on activities in the SDL cycle that give us best bang for buck, and then use automation to automate most of the elements of the cycle. Because if we can have a car that can be driven through automation, I'm sure we can figure out how to do testing and a whole lot of other stuff. That's it for me.
Brooke?
I'm encouraged. I mean, I'm with Jim, and especially in that I just got to keep taking a step forward and doing the best I can. And also, it's important for those of us who care about this to talk about this and to kick it around and find out what works and share that. It's very important. Because it's complex. I mean, that was how we started. That's how Jim started. It's complex and it's a big field. It's multivariate. It's multidimensional. So that, that makes it a difficult problem. I will say I'm encouraged by a couple of things. When James and I were trying to figure out and set down our generic SDL for this next book, I wanted to take Microsoft, because they have such a mature SDL, use it as an example of how they're still tied to certain assumptions about the way software is built, which I think you have to get rid of in your SDL. And I went out to their site to get the most recent documents, and they'd taken out all of the assumptions about timing, about SDLC, that is software development timing. They removed all of that from their SDL, and they had a new revision, just like we were putting in our book. And I'm encouraged by the idea that we're finally getting, at least we have a consensus about what people should do. We call it different things. We chunk it up differently. That's okay. But there's been a long-term consensus about what makes holistic software security. There is a long-term consensus. Catherine Blackadder Nelson and Bob Hale and I at Intel spent 18 months looking at every extant SDL and realized that there was a lot of consensus even then, and that was 2015, 2016, wasn't it, James? Because I was working at that point, somewhere around there. Anyway, that hasn't changed. We know what we need to do, at least at the current state of the art. Okay. Now, how do we express that so that developers can actually do it and actually care about it? That's kind of the big problem here. And so that executives realize it's a thorny problem and can invest in it and care about it. Those are kind of the bigger issues. But I'm encouraged that at least we're starting to get out there some models that can be used and that aren't tied to somebody's particular way of building software. That's really important right there, because it means that people, you know, one of the big problems we had at Intel was everybody was doing Agile, since their SDL was very waterfall. Everybody was doing Agile said, not me. It doesn't matter to me, because that doesn't make any sense. We don't build software that way. And we have to get rid of that problem first. We have to make the SDL possible, doable for everybody, understandable, approachable, organic, integrate, which gets back to what Jim was saying and Anmal were saying. If you're not working with developers, what are you doing? Somebody in the chat said that it was security's problem that bugs are getting out. No, I'm sorry to disagree with you, but if it's not, developers are not interested, we've already blown it, in my opinion. So I'm encouraged by some of these developments. We're making some movements, and Anmal and Jim put out a bunch, but I think we've got a long way to go. RSA is not the big celebration of how great we're doing in software security.
Yep.
I'll just point that out.
Mike, I'm going to close this
I'm
up
done.
with just one statement from a management standpoint, because I think we still have a lot of CISOs and others that are on the line. One of the things that is very promising for me that I see for the future is the advent of the Chief Product Security Officer. Very much like when I retired out of the government in '97 and came in to have a CISO role, the titles weren't there, but the role was there. Actually, Heidrick and Struggles now, most of you know them as a pretty mainline recruiter, they're actually recruiting for those roles. And so what are they looking for? They're looking for people that have come up through the ranks in engineering that know security. They're not going to be the CISO, but they'll have a dotted line into the CISO depending on the culture of the company, but they'll have a separate role that's there. That's going to change the dynamics both at the board level and what you're going to get from a budget level and so forth. But since we're short on time, I'll save that thunder for another time, because that's a 1 hour topic into itself. So again, Mike and crew, we really appreciate you guys inviting us to participate in your, as a panel today. And it's great to see some names I recognize here. I'm going to have, now that I'm finally, after 23 years, finally on LinkedIn, I'm going to have to go reach out to all these folks too.